talking about the DO-160 is the RTCA DO-160, which is formerly known as the Radio Technical Commission for Aeronautics. They're kind of they got 200 committees, and they act as an advisory board to the FAA on, standardized testing requirements to meet the test requirements cert for the PMA part. The DO-160 and its precursor, the DO-138, has been a standard for environmental testing since 1958. It's kind of governs all of the testing aspect of commercial airline testing and for airborne equipment. So in essence, its existence is to come up with a standardized testing means to reproduce the environments that would be seen on the aircraft. That's in short, temperatures versus electrical environments, so that we can reproduce that in a controlled environment and ensure the product that is being applied for certification meets those requirements and is sustainable in that environment. So this is kind of a breakdown of the different categories or test sections, as we call them, for DO-160 from the Rev G, which is the latest DO-160 at the moment. You can see sections 4 through 14, as well as 24 and 26 of what we would consider environmental test conditions, whether it's temperature or altitude, humidity, vibration, things like that, that are more environmental conditions. And then sections 15 through 25, again, save section 24 would be more your electrical EMC, EMI type categorizations for certification. Each of these test sections, dependent upon your placement on the airframe, are applicable in some fashion. Depending on where you're located, you may not have all of them, or depending on your criticality to the safety of the aircraft, you may or may not have to do each and every one of these or a subset of them to prove your component meets the testing criteria for certification. So kind of just a little rundown real quick of which each section is. When we talk about temperature and altitude, it is truly just temperature. Can you handle the extremes, the hot, the cold that you're going to see in that environment, as well as the altitude? 70,000 feet, is your product going to have an issue operating with that in that vacuum environment? Temperature variation is how does it do with the extreme changes in temperature, going from Phoenix, Arizona at 120 degrees, and you're up at altitude and it's negative 30 or 40 outside in a matter of minutes. What's your product going to do in those scenarios? How does it respond? Humidity, same deal. Higher levels of humidity, up into the 90%. Is your product going to have short circuits on the circuit boards, or is it going to function as intended? Shock, crash safety. This is still, again, how's it going to handle mechanical shock, any kind of impulse to the airframe? Does it break loose and become a projectile? Does it start to tear apart the rest of the airplane as it breaks loose in those environments? Vibration, everybody's familiar with the vibration of a aircraft or even your car or anything as you're driving down the road. There's always some level of vibration there. Does it create stress to your bolts, to your mounting structure, to the point where over time they break loose and again become some sort of projectile or other things? Or does it shake a board loose and complete shut down the unit altogether and it fails to operate? Explosion proofness, this is kind of a fun one to watch in the test environment if you're not familiar with it. We put it into a vacuum and we put a mixture of combustible gas into it, and then we turn your product on to see if there's any ignition source within the product to light that combustible gas. And if it does, it lights the gas off and it blows up. And then if it doesn't, we have to prove that the gas was flammable enough to actually ignite, and we have to ignite it. So either way, you get an ignition. It's a lot of fun to watch. Waterproofness, how does it handle the environment of water, rain, dripping water, pooled water, depending on the conditions of your product, what level of severity is applicable. Fluid susceptibility, what happens to your component if you spill a can of soda on it, or what happens to it if you have cleaners, solvents, fuels, depending on your location within the aircraft, Does that cause a failure within the product? Sand and dust, again, if you're external to the aircraft, does blowing sand, blowing dust in the desert environments gum up the product? Does it get into your fan blades? Does it cause an unexpected shutdown of your system? Fungus, as you're sitting in a humid environment, a hot, humid environment with inorganic salts available, do you start to grow fungus that could corrode your boards or cause failures on your system as well? Salt fog, kind of your beach environment. You got this humid, salt, corrosive environment that over time does corrode a majority of items and parts. Is your system able to function? Over that time, and it's kind of an accelerated corrosive test. Next slide, please.
Hey, Kevin, does the DO-160 standard apply requirements to each one of these sections?
Yes, and again, it depends on your a few things. Your location within the airframe. Again, if you're external, you're going to be seeing more of the sand and dust type requirements, and if you're the coffee pot in the kitchen, clearly you're not going to see blowing sand and blowing dust in that environment. But then also your criticality to the safe operation of the aircraft will drive up, what you see, and also the severity of what you see. The more extreme temperatures, the more extreme some of these conditions, specifically when we get into the EMI, the higher level voltages, the higher level lightnings are applicable based on your function to the aircraft and your placement within it. And they give a category dependent on where you fit, and each one of these tests will have criteria based on that to decide to find those levels. So the EMI stuff, the magnetic effect, this is kind of this is an old test that's been around, but back 50s when this 60s were being developed, the magnetic effect is how your product impacts the true north of a compass. So we would turn your product on. We actually use a compass. We slide it closer to the product and see at what distance does it change the compass by 1 degree. So if you're flying along and you're off by 1 degree, it could be a big difference of where you end up. As we move towards GPS and Hall effect sensors and stuff, this test is still done to see how it affects the Hall effects and other things within the aircraft for the magnetic components that are produced by the test article. Power input testing is power surges, power transients, engine starting, when they crank the engine and the voltage dips and it goes up and down, power surges, frequency transients if you're an AC product, current harmonics, all falls under power input. Power input, I think, is the single largest text section within all of DO-160, partially because there's so many different variables of input power, from your basic DC to single-phase AC, three-phase AC. Then they get into constant frequency, which is your 400 hertz products, to a narrow frequency to wide frequency, which could be 360 hertz to 800 hertz, and anywhere in between. And there's different criteria that you have to reproduce to try to hit on each of the potential phenomena that you would see on the aircraft. So, if you're a wild frequency at 360 to 800 hertz, you might have to test it at increments of 20 hertz to prove that your system will handle the entire spectrum of that. Or sometimes you do the low, middle, high, and it just extends out the amount of testing dramatically in that case. Voltage spike is kind of your power line transient from a switching effect. So you turn a switch and you get a voltage transient. This is a 600 volt, 10 microsecond wide pulse with a less than 2 microsecond rise time. Believe it or not, it does cause quite a bit of failures in the testing industry. Audio frequency conductive susceptibility is your low frequency, your audio frequency ripple that you would see present on your DC and AC power input lines. So we would reproduce that ripple voltage on your input power line to see how your product responds to that phenomena. And then induced signal susceptibility is kind of the so in the DO-160 they have what they would consider your input power lines, and they have what they would consider your I/O lines, your communication lines and things like that. So they're trying to reproduce the same phenomena we just kind of talked about with your audio frequency susceptibility, your voltage spikes on your I/O lines, and that's where induced signal susceptibility comes in. It would be kind of a coupling type test where you would wrap your I/O lines and simulate an electrical field going through the wire, and how does that couple onto your I/O lines. Also a magnetic field, how that couples on. And then there's also a voltage transient, we call it induced spikes test, where you chatter a relay to show if there's a relay chattering on a power line or on a line next to your I/O line. Does that couple onto your line? Does it cause communication issues within your system? And then again, there's an electric field and magnetic field that we induce into the actual chassis of the article to show that it can handle those environments as well. And then you're kind of backbone of the DO-160s kind of get into the what they call the emissions and susceptibility are kind of key components to the DO-160 and lightning as well. But RF emissions and RF susceptibility are radiated frequency or radio frequency radiated susceptibility or radiated emissions, and radio frequency conducted emissions or conductive susceptibility. So this is measuring the RF energy, how much RF energy is produced by your product. Is it under the applicable limit based on your location within the airframe and your criticality? And then in reverse to that would be to transmit that RF energy onto your product through either radiated susceptibility, which is through antennas, or conductive susceptibility, which would be through some sort of injection transformer probe, and we would inject it onto each individual bundle, I/O line, power line, to show that your system can handle those environments, or inversely don't produce more than the allowable environment. And again, as you move more external to the aircraft, the levels exponentially grow. You can see as high as pulse modulated radiated frequency testing for susceptibility as high as 7,200 volts per meter if you're external and critical to the airframe. And you can be seeing it as low as 1 volt per meter if you're really internal and have no impact on the criticality of the plane at all. So it varies tremendously based on, again, how critical you are and to the flight and your location. What determines the scope of the testing, I see the question coming up, is really, like I've been saying, what the part does, in terms of functionality within the airframe, where it's located within the airframe, and all those parts come into play. Usually that's an agreement between the certifying authority will get a test procedure that says, here's the test plan, here's the test we intend to test, here's the criteria we believe we fall under, and you would present that to the FAA for approval. And when you gain that approval, then that would be the testing that you would go and apply. So NTS, yeah.
I apologize. Is it too simplistic to state that mechanical products typically would be on the environmental side, salt, fog, humidity, temp variation, while the electrical components would be more an array of DO-160 testing relative to RF testing?
The RF testing, yes. Anything electrical would be falling under the EMI, but the electrical also has to meet the mechanical requirements of the environmental tests, while a mechanical actuator with no electrical components would only have to meet the environmental conditions and wouldn't have an electrical cert as well.
And
so again, it's functionality and location or what drive what tests are applicable.
And the second part of the question said, who can sign off that the test goals were met? If NTS does that testing or any test supply house, we would sign off via test reports, engineering analysis with data to show that the test was performed, how it was performed, the exact results that were obtained, were they within the margin of the requirements, and if they were certified that the product met the spec.
Correct. And that's based off of the test procedure that is pre-agreed upon between the certifying, the entity looking to certify and the FAA or whoever the certifying body is. They would come up with pass-fail criteria for that particular component. Your voltage must maintain between whatever 1 and 2 volts, whatever the criteria is, and it has to continue to actuate. And we would do the test and say, yes, it did. It met those criteria. We applied the threat per your procedure. You passed this particular test, and here's your test report that you would then supply to that, the governing body to gain that certification.